What up, coders? Today we're going to be solving a Google coding interview question. So if you're applying for Google or you're going to interview at Google, you know, this could come up at any company realistically, but this is asked by Google according to Code Signal. If you want to check this out, it's on Code Signal in the interview practice section. So we're doing first duplicate. So here we go. So instead of reading that problem description, I think it might just be better for me to explain it to you guys. Like, it's kind of mumbo jumbo sometimes, and they explain it weird. Basically, they're going to give us an integer array. So let's say I'm giving you an integer array. That means an array of numbers, right? So this is an array of numbers, this is an array of numbers, this is an array of numbers too. But what the constraint is the values in that array, those values, these values in the array, the numbers in the array, they have to be between 1 and the length of the array, right? So the numbers in the array can only be between 1 and the length of the array. So nothing less than 1, so 0 is less than 1. So, you know, that cannot be part of the array, so this is invalid. That's why there's an X over it. And anything greater than the length of the array is wrong too, so that can't be in there either. So you could see the length is 1, 2, 3, 4, 5. So nothing greater than 5 should be in this. And there is a bunch of stuff greater than 5. So this is just, you know, pretty much garbage. Now, this could be a valid input, right? Because the length of the array is 1, 2, 3, 4. It has values between 1 and 4 only. So 1, 2, 3, and 4 is perfectly fine, right? This is also valid because the length of the array is 1, 2, 3, 4, 5. And it has values between 1 and 5. It doesn't have to be all the values between 1 and 5. It just has to be the values in the array just have to be between the boundaries of 1 and 5. So, you know, there could be multiple 1s, there can be multiple 2s, multiple 3s, whatever. It just has to be between 1 and the length of the array. The values have to be in there. Okay, we get it, we get it, we get it. All right. So now what we know we're given, now let's look at our goal for this problem. We're given this array. What's our goal? What do we have to do with this array? All right, so now that we understand our input, let's look at the objective. So we know that our array can have duplicates, right? There could be duplicate values, right? And I've labeled some of these here, right? You could see in this input array, we have 2 1s, 2 2s, 2 3s. In this input array, we have 2 2s, 2 3s, right? So let's assume that most of our inputs are going to be duplicates. This is some kind of real world problem where we have a bunch of arrays of duplicates. Probably doesn't come up too often, but it might, maybe. We have thousands of numbers, and maybe a lot of them are duplicates. And what we want to do is we want to find the first duplicate. And that is the name of the problem, right? So what does first duplicate mean, though? Does that mean, like, okay, 1 is the first duplicate, 2 is the first duplicate, right? It's the first number. No, 2 isn't the first duplicate in this input. So what we're going to go by is the second number of the duplicate, the second number. So, you know, this is the first number of a duplicate. This is the second number, first number, second number, first number, second number. We want the first occurrence of the second number. So this second number occurs before this second number and this second number. So it's the first second number of all of the duplicates. So that is going to be the value we return. So we're going to return 1. We're going to return this 1. In this array, we have 2 2s and 2 3s, but the second occurrence of 3 comes before the second occurrence of 2, so we're going to return 3 in this input. And in this input, there are no duplicates at all, so when there's no duplicates at all and you can't return anything, you're just going to return -1. If there was just one duplicate, that would be the value you return. But yeah, that's pretty much it. Hopefully you guys understand. So your objective is to find the first duplicate, meaning the second occurrence of that duplicate comes before the second occurrence of any other duplicates that exist. If you cannot find any duplicates, you just return -1. That is your objective. All right, it's time to accomplish this objective. How do we do that? There are usually multiple ways to solve problems, some better, some worse. We want to do things fast in computer science, so we want to get that time complexity as small as possible. We want to get as fast as we can to solve this problem. Because if we had to do thousands and thousands of data, like arrays and numbers and stuff, you know, it can end up taking a long time. So we want to get our time complexity pretty low. So first thing I'm thinking, like, brute force is the worst solution, right? So usually it's the easiest one to come up with. And oftentimes it's going to be that O of n squared solution. And in this case, it's going to be that O of n squared solution. So in this case, I'm kind of thinking, like, if we look for every duplicate, like, we could loop, like, the first thing I thought of, I was like, okay, well, if we loop through the array one by one, you know, you find it, you start at 2 and you go, okay, and then you could see duplicates, and then it's like, okay, how do you know? You need 2 pointers, right? So if we have 2 pointers, we have 2 pointers, and then for each number, so I'll leave a pointer here, and then we take our second pointer and we go boom, 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 and we find the duplicate. We can keep a minimum variable, maybe something like minimum index of duplicate second val. That's a very, very long variable name you wouldn't want to use, but I want to be descriptive here. We would want to keep track of the index that is minimum, where it's a second value where we see a duplicate, right? So we see this 2, and we get down here, and every time we see a duplicate for the second time, right? We see all this value. Whenever we find a duplicate, so the second number of the duplicate, we're going to check for the minimum. We're going to update our minimum index to see if we can find, we want to find the minimum index, right? So in this case, we have 0, 1, 2, 3, 4, 5. 5 is the index of the second number here, right? So we found a duplicate, second number's index is 5, right? So we update it, right? Now, we're going to move our arrow, right? We got to the end of the array, now we're going to do another number. And we're always starting with our arrow at I plus 1. So, you know, the red one would be I, and the yellow one would be I plus 1. So we're going to start here. So this equal to 1, this equal to 1, this equal to 1 now. Okay, next number, 3. And then we go boom, boom. Oh, we found another 3. Now, we are going to check against our minimum, which is set to 5 right now. This is index 4, so 4 is less than 5. So this will be updated. So we've updated our minimum index because we found an index that was smaller than 5. So it's 4 now, and we keep going. Okay, and then you go through the rest of the array. There's no more duplicates, so nothing's going to happen. And yep, that's it. So they both end. And there we go. We found the minimum index of, you know, all the duplicates. So all the duplicates, we keep updating a minimum with the minimum index of the second number we see. And at the end, it's like, okay, we have the index, so how do we get the value now? Well, you can just access array of the index, and you'll be able to get that value, because this array of 4 is going to give us the correct value, 3, and that's what we want. So here's what our code would look like for that solution. You can see we have this, I shortened the variable name, min second index is set to the length, because that's not even a valid index. We're making it big as possible, so that we can update it with a minimum. Then we loop through. This outer loop would be our red pointer, like our red arrow, and this inner loop would be, you know, the J would be our yellow arrow. So the red arrow, and then the yellow arrow goes, you know, one at a time, looks for all the duplicates. If they match up, you know, then we update that minimum, just like we did a second ago. And we update it with the minimum of J, which would be the yellow arrow, looking for that second value, and the current minimum. And the current minimum starts at length, which isn't even an index. So the first time we find a duplicate, it would update to J immediately. And every time we find a duplicate where the index is less than the minimum of the second value, we update that min second index. And if it remains the length at the end, we know we didn't find any duplicates, so we return -1. Otherwise, we just return that value, right? So this is a double for loop solution. And if you guys know anything about time complexity, you'll know that a nested double for loop solution like this is going to have a time complexity of O of n squared. O of n squared is not something that Google is going to accept, or any of these big companies for that matter, because we can do much better, right? What this O of n squared means is that if this array is size, you know, 10,000, it's going to take O of 10,000 squared time to solve that problem, right? But what we want to get it down to actually is linear, right? So O of n, so that it's, instead of 10,000 squared, it'll just be O of 10,000 time to solve this problem. So if we want to get this down to linear, that means we're going to want to get rid of this pointer. And that means that we're going to want to make it so that we're just doing one for loop through the array somehow and getting that minimum second value index. Now, how can we do that? Well, one thing you guys should know is that space complexity can be used to speed up time complexity. so that we can use like a data structure or some kind of storage to store things while we try and solve a problem and speed up our time complexity. Instead of doing that double for loop, maybe we could store something, check back in with it, and use that storage to speed up our answer. So one data structure that comes to mind when we're dealing with duplicates or unique values or something like that is a hash set. Whenever you hear duplicates or unique values, think of hash set. A hash set is built specifically to keep track of unique values, and it's really good data structure because some data structures, it takes time to access the elements of them. So you store things and it'll take time to access stuff from them. Hash sets, constant time, no time. It takes no time. So when you access things from the hash set, this is a set or a hash set. We're going to be putting things in. We can access things that we put into it back from it in constant time, meaning it doesn't take any time at all. So let's have a hash set. And here's the idea. Let's loop through these numbers one by one, and let's add them to the hash set. And the first time we see one that's already in the hash set, that is going to be the first duplicate that we see. So let's just walk through this example, right? We see 2, right? So we're going to say, is 2 in the hash set? No. Okay, so let's add it in the hash set. Okay, 2's in. All right, now we look at 1. Is 1 already in the hash set? No, it's not. So let's add 1 into the hash set. Now we look at 3. Is 3 already in the hash set? No, it's not. So let's add 3. Now we see 5. Is 5 already in our set? Nope. Let's add that. Okay, and then we see 3. Is 3 already in? Yes, 3 actually is already in our set, so that is our first complete duplicate. We already saw it once. These are our seen values. And we saw the second closing one, and that means that was the first duplicate that we found. That was the first one, because we saw the first part of it, and that was the first closing one we saw. So that's pretty much how you do it. Let's just code this out really quick too. So in Java, it's called a hash set. In other languages, it can be called anything else, like a set in Python or something like that. So you can just make it seen, just initialize it. It's just a basic for loop. We're looping through all the numbers in the array. And then you're, if you can check using, these are constant time checks, like I said. So if scene.contains a of I, so if we already have the value in the hash set, then we return that value because we already saw it in there once. Otherwise, we just put it into the hash set, right? Just like we did. So we just do scene.add. These are just methods on the back end of a hash set. If you don't know about hash sets, I'd recommend looking them up a little bit more. There's some really good videos. HackerRank, Gail Lockman-Vidal talks over these. And we return -1 if we don't see it. Right? You can see how it's looping through each index in the array. It's adding them to the hash set until it sees it. You know, it's saying, is it already in the hash set? If it is, then we saw it twice. So that's the first complete duplicate. We return, we're out of the function. So that's the first time we see a duplicate. Otherwise, we're just adding it each time until we see the complete duplicate, right? Get it? Yes. The only downside to this solution, like this is a good solution, right? This is linear. So we went from n squared to n, huge difference, right? That's really good improvement. And Google would probably be happy with that. Big tech companies would probably be happy with that. Like that's fast enough. The only problem with this solution is that now we're using space, right? This takes up memory and we don't really want to do that if we don't have to. So although we're fast enough, this is O of n space, assuming like maybe everything's a duplicate and we have to put a bunch of numbers in and maybe the first duplicate is one of the last numbers. So this could essentially waste a lot of space that we don't really want to do. So if there's a way we could do this without space, we would definitely want to do that and impress our interviewer. So with a little bit of creativity and critical thinking, there actually is a better solution. We can get this down to linear time, no extra space. How the heck do we do that though? It is not intuitive at all, but there is one thing we never thought about. And this is important. When I read Cracking the Coding interview, they made it very clear that every detail of a problem matters when you're dealing with these algorithms, data structures problems. These interview questions, they're not putting things in here for no reason, right? Have we ever stopped and thought about why the values have to be between 1 and the length of the array? We never thought about that. Well, you know, we just were like, oh, okay, that's fine. But there is a reason, because with that information, we can use that and actually construct a solution. And it's very tricky, but this is the solution. If we know that the values are between 1 and the length of the array, then that means that these values, we can use them as indices of the array as well. And the trick we're going to do here is we're going to take the current value as we loop through, and we're going to take that index minus 1, because if we took, index 5, you could end up going out of bounds if you had like the maximum value. If the length is 1, 2, 3, 4, 5, 6, say we had a value 6. If we took index 6, that's out of bounds, right? There's no index 6, it's only up to index 5. So we're going to take the index minus 1, right? So 2 minus 1, index 2 minus 1, which would be 1. So 0, 1, 2 minus 1, which is here. And we're going to make that value negative, right? And while we loop through these values, we're going to keep going. And the next time we see a 2, we're going to check if the value's index, if this index minus 1, so 0, 1, 2, this index minus 1 is already negative. That's how we know we found our complete duplicate, right? So let's just run through this example here. So we see 2, right? We're going to look up this current array, index 2. So this is index 0, this is index 1, this is index 2. Minus 1, so we don't go, because we can't go out of bounds. So this is the first element. And is this negative? No, it's not. So we're going to make it negative. Okay. All right, we're at the next element. This is negative 1, though, because we changed it. So there is no array of negative 1, so that's out of bounds. So we're actually going to have to use the absolute value to get the original values, right? Because as we move this red arrow along, we're not checking for negatives right now. We're checking for negatives when we do that lookup of the current value as an index minus 1, right? So we're going to use the absolute value as we go through so that imagine that we're not using negatives. We're not modifying these. We do the map.abs as we do the regular for loop. You'll see that in the code. And then when we look this up as an index, we're looking up 0, 1. Okay, it's this element minus 1. So we make this element negative now. Now we're at 3, so we look up array of 3, 0, 1, 2, 3, minus 1 is array of 2, and we make this one negative. Just happened to be it. Now we're at 5, we look up array of 5, 0, 1, 2, 3, 4, 5, minus 1 is 3, so we make this one negative. Now we're at 3, again, the absolute value, so we look up array of 3, 0, 1, 2, 3, minus 1 is this. It's already negative. So that was our first duplicate that we found, and we returned that value. So when you do that lookup of the index minus 1, and you know and you see it's already negative, that's when we found our duplicate, right? Because the whole premise or idea here is that this 3 is when it looks up array of 3 minus 1 or array of 2, it's going to look up 0, 1, 2. It's going to make this negative. When this looks up array of 3 minus 1, which is 2, it's going to the same spot. So it makes it negative here the first time, and then when we see it again, it's already negative. So when we see it's already negative, when we do that lookup in the code, we found our first duplicate. We return that right away. So it's a little bit confusing, it's a little bit jumbled up, but if you look at it for a second, it's exactly what we just did. You're looping through, right, the red arrow, this for loop, looping through element by element, and every time we see an element, we're looking the array of the value of that element minus 1, so that index minus 1, and we're making it negative, right? That's basically what we did. And then when we look up the value of that minus 1 as an index, we look that up, and it is negative already. That's when we found our first duplicate, and we just return the math.absolute value of that element. Otherwise, we return negative 1 if we don't find any duplicates. So you're making those values negative, once again, because when you see a 2 at the beginning of the array and a 2 at the ending of the array, when you see those duplicate values, they're going to map to the same index based on this, because it's just the value minus 1. They're going to map to the same index. So you set it negative once at that random index that it maps to, and then you see it again later. It maps to the same element, and it sees it's negative, and we are able to check that right here and return the value of that element. Those are the final, that's the final and best solution, right? That has no space. That is a linear solution. That's optimal. Google is gonna, you're gonna pass your interview if you come up with this solution. Those are 3 solutions. The first one being brute force, second one being pretty good, but this is being optimal. And yeah, that's it. Hopefully this helps you guys pass your interview. Let me know how you like this style of video. This is my first drawing video. And please like and subscribe so I can help grow my channel. Also, please support me on Patreon. Got the link below, and I have study guides for the technical interviews down there. Thanks for watching this video, and I will see you guys in the next one. All right. Bye. Peace.